All right, we're gonna do a little trig homework uh, video today. So I'm gonna go through the questions on the trig homework, and then answers will be posted. You guys can check them out if you'd like, just in case you want some extra help. I think this is a really important topic, so that's what we're gonna go through and do this. So start with the first one, 292. We got a canoe approaching a lighthouse on the coastline of a lake. Front of the canoe is 1.5 feet above the water, and the observer in the lighthouse is 112 feet above the water. Now, what this means is, right, that the actual, if we want to call it like ground level, right, is actually 1.5 feet below here. So if we measure from the water up, and this is 112 feet, right, there's actually a 1.5 foot gap, or we want to say overlap, from where the water level is, from where the guy is in the boat, right, to the groundwater. So technically, from his height up is actually 112 minus 1.5. That's actually the length from the guy up, and that's really what we're going to be drawing our triangle from, is the tip of the canoe forward, if you want to say. So not really the line down the bottom, but this line right here that measures from the top of the canoe up, because that's where we're measuring from with these sight lines coming down. So if we subtract this out, we get 110.5. This is the number we actually have to use for the length of this leg of our triangles here. Now, two things. Number one, we know that when we started at 5 o'clock, okay, the observer in the lighthouse measured the angle of depression. That was 6 degrees. Remember, that's the measure of this angle here and this angle here. Those are both 6 degrees, okay? In the other angle, the angle of depression, it says is 49. So that's this angle. Maybe this will work. The old lick the pen, scribble the drag. Not happening. The other option we have is if this is 49, then so is that. Okay? Remember, angle of elevation and depression we always put in the bottom corner of our triangle. All right, so now if I'm actually wanting to solve the question, I need to know the average rate of speed, right? Average speed of the canoe traveled toward the lighthouse. So I like to call this the DIRT formula. Distance is equal to DE, rate times time, DERT, right? Like Joe Dirt, all right? And what happens here is if you're looking for the rate, you just have to divide both sides by time. So the distance divided by the time is equal to the rate. So we already know the time because it said that he started at 5 o'clock. And then it said 5 minutes later. So we already know that the speed, and it's foot per minute, so we're counting in minutes. The time is already 5. What we need to figure out is the distance traveled. And really, to get this distance from here to here, right, I need to subtract the entire length, okay, minus this part right here. So I just need to do this part minus the whole thing. And really, all we're actually doing now is looking at two different right triangles. I have the small right triangle, okay? This is the first part we need, which is right here. And I know that this angle is 49 degrees. I know that this side is 110.5, and I'm looking for this piece. Let's call it S for small, okay? The other triangle I have is I have the really, really big triangle, right? And we know that this is 6 degrees. This is still 110.5. And we're looking for this one. We'll call this L, right, the large. And then the side we're looking for, we call it medium if you want, would just be the large minus the small. That's it, okay? We called it X, so we'll just keep it X, all right? So that's what we're looking for here. So in both triangles, notice that our angle measure, okay, is given. We have the opposite side in both of them, and the adjacent side is what we're looking for in both of them. So this is just a SOHCAHTOA question. That's it. Okay? So we'll start with the first guy over here. The tangent of my angle, okay, is equal to the opposite leg over the adjacent. So the tangent of 49 is equal to 110.5 over S. So Look what I got. Haha, calculator time. Okay. So I grab calculator. I'm going to type in. Now, at this point, we actually are going to cross multiply. Okay. So if I cross multiply, it's just going to be the tangent of 49, right? S times that is equal to 110.5. And we divide by the tangent of 49. So 110.5 divided by trig tangent 49, not 4 squared 9, but 49. And we end up with, oh, look at this. I love this part when errors pop up. Negative. What is going on? Remember, we talked about in class, I can get the cursor up and move it up to here, and we'll see the angle says radian, right? So if I click on this is the battery. I want to go to document settings, okay? Remember, what we talked about in class one time is we want to actually change the float. Float means, now the different decimal things is, this is going to round to the 10th, hundredths, thousandths, 10,000ths. That's the decimal place it's going to round to. If you pick float, it'll give you the most amount of decimal places that it can. It won't round it. It'll just give you as many as it possibly can here. So after we pick degree, we just click on the angle, right? And we just pick what we want. So click it. I can select radian and degree. Now your calculator is going to be what we call press to test mode. I'm just pressing the tab button here, and I'm going to go down to make default. I'm not going to change anything else. You want to apply your settings for the new document scratchpad, of course. We're going to hit yes. Now all I have to do is go back up and reselect this and hit enter to recalculate. And now I end up with this number. Now remember, I'm not rounding yet to the very end, so I get left with that. So we're going to write S is equal to 96.0561845,287. All right. Press to test mode just will let it put it into degree mode for you. And then, so if you look, right, here's press to test mode. So we can set it in degree, and all of these lovely things will be disabled here. They'll be enabled, so that it's not going to do anything different for you. The only thing that's going to happen is you can't open any apps. So it prevents anyone from creating something that'll help them in the exam and then accessing it. Won't let them do that. So that's the deal. All right, next one. Same thing, we do tangent. We took 6 degrees. The opposite is 110.5. The adjacent is L, and it's the same process. Cross multiply L times the tangent of 6 is equal to 110.5 divided by the tangent of 6. All right, and I'm going to go and just pull back the question we just did, change 49 to 6, and there's my answer. So this is 1,051.33727,219. And then all I'm going to do here now is the answer, x, is equal to the difference, right? So it's 1,051.33727,219 minus 96.0561845,287. And x is going to equal, and then I'm going to arrow up, select this, put the minus sign, back up, and there's my answer. Now, 955.2810876663. And remember, we're doing that's the distance. So we want to do distance divided by time is equal to the rate. So we take my answer. We divide it by 5 minutes. And that means that the rate is, and we're going to the nearest foot per minute. So this is going to be 191 feet per minute. Now, you crew people, is that fast? I have no idea. You can tell me. All right. 295. 20-foot support post leans against a wall. Draw a picture. Wall, right? Support post. making an angle of 70 degrees with the ground. So there's my 70-degree angle down here. Nearest tenth of a foot, how far up the wall will the support post go? Now it's 20-foot support post, so that's the post. This is the diagonal here. That's what we're kind of looking at here. All right. We want to know how far up the wall goes. That's this side. So angle, we have the opposite side and the hypotenuse. Remember, so, S-O-H, ka, C-H, T-O-A for TOA. Okay. We are going to choose so because it's O and H. So the sine of the angle is equal to the opposite over the hypotenuse. And then we're just going to plug in here. The sine of angle 70 equals opposite, which is x over 20. Now in this case, we cross multiply and we are done. Okay. Calculator. I do 20 sine 70, and there's my answer. And it's 18.8, and so we choose choice 4. Okay, 296. Show the diagram below. Angle of elevation. Remember, elevation always in the bottom corner, and depression. Point of the ground at the top of the tree is 34 degrees. What is the point 20 feet from the base of the tree? So the base of the tree is down at the bottom, so this is 20. What is the height of the tree to the nearest foot? So once again, angle two sides, that's SOHCAHTOA. Here we're going to talk about this as the fact that this is the opposite and the adjacent. So I do tangent of 34 is equal to x over 20. And all I have to do is cross multiply once again. 20 times the tangent of 34 is going to equal x. And then I'm going to take my calculator. 20 trig tangent 34. And we get 13.49, which is 13.5. Okay. $298. Kathy wants to determine the height of a flagpole shown in the diagram below. Uses a survey instrument to measure the angle of elevation to the top of the flagpole and determines the top of 39.4 degrees. Now remember, elevation depression, bottom corner. Okay. Walks 8 meters closer, determines the new measure of the angle of elevation to there. The survey instrument is 1.5 meters above the ground. Determines the state the nearest tenth pole height of flagpole. So we're actually looking for is this. But remember, the actual height of the flagpole is actually that height we got here plus another 1.7 meters. Okay, so we have to add that on at the end to get the final answer. So, how do we figure out the height of the flagpole? That's the question, right? Now, we know that this is 8, okay? But what we really need is to get in this triangle or in this right triangle, we need to get this, either this side or that side over here. If you think about it, we have these two triangles again, right? We have this is 52.8, this is x, and then once again, okay, this is 34.9, and this is x. And we know that the piece out here is 8, so the question is, how do we get either this or that whole thing? That's what we want to know. Now, what we can do is actually use the law of sines on this piece of the triangle here. So if you think about it, there's actually this third triangle here that has 34.9, right? 8 for this piece, and we're trying to figure out this. If we can figure out what this length is right here, I can use this hypotenuse to then help me figure out that leg. So that's an option, okay? And this is a law of sines question. We haven't done a law of sines, we didn't talk about it that much, so let's do it right now. Now, the only thing we need is we need another angle, right? We don't know that if this was 90 degrees, this would be easy to figure out, but it's not. But we do know the angle that's right next door to this one. So if we do 180 minus 52.8, we can get it, and that's 127.2. All right. Now, we also could figure out this side, right, and use the big triangle. So there's a couple options here. But let's go and find that side because that's the one we identified earlier. Now, to do that, we are going to need to know the measure of this angle because we need the side across from it. Okay? So that's what 8 is. So we just have to figure out that if we have 34.9 and 127.2, that's a total of 162.1, and with the 180 degrees, it should be 17.9 degrees. There is another way to get that as well, which is we can use the exterior angles here, right? 52.8 outside, plus these two remote interior angles. So by subtracting 34.9, we can also figure that out. Okay, so here's the deal. We're using these two angles, right, and these two sides to figure out what y is. So we're going to do the sine of A over side A is equal to the side of angle B over sine B. So A and little a, B and little b, and let's do it. So the sine of A, which we said over here was 17.9 over side A, which is 8, is equal to the sine of B, which is 34.9 over side B, which is what we're trying to figure out. Cross multiply. B times the sine of 17.9 is equal to 8 times the sine of 34.9. We can divide out by the sine of 17.9. And then B is equal to, now I'm going to grab control divide for the fraction. I'm going to do 8 sine 34.9 on the top, and then sine of 17.9 on the bottom. And I end up getting that guy. So that's what B is equal to. So this is 14.8920398081. And that's what this is. So now I can do SOHCAHTOA here, right? I have the angle. This is my opposite. That's my hypotenuse. So now I can just do the sine of 52.8. Should be a decimal point there, 0.8, okay, is equal to the opposite, which we're calling x, over the hypotenuse, which is 14.8920398081. Cross multiply. I know how much you guys like writing all these really big numbers, so we're going to do it a whole bunch of times. Times the sine of 52.8, and then I'm going to type that in my calculator. So sine 52.8. Make sure you close the parentheses. Go grab that other number, bring it down, and I end up with 11.8619. And remember, x plus 1.7, which is the actual height, and now I can round it, okay, to the nearest meter, nearest tenth, is going to be 13.6 meters. All right, that's it. That's our height. Yay. Okay, there is another way to do this, which is if I use this, really, I'm looking for this, right, and I call this x, I can refer to this as x plus 8. And so I can treat this as a law of sines question, because if this is 34.9, 90 minus that should equal, in this angle then, is 55.1. Now I can do a law of sines this way. It gets a little trickier that way, but that's an option for us. The other option is to call this, now remember, we can't call these both x, so we need to get another thing here. This is, let's say, z. This is z plus 8, or if we call this z, this is z minus 8. This is, I think, is probably one of the easier methods, is using that law of sines here. So we're gonna just stick with that for this part. 299. If you're having trouble, feel free to stop by. We can talk about that one together. Okay. I realize this is getting a little bit long, so we'll finish up with these ones, and I'll make a second video for the next part. Okay. Window of a house is 15 feet above the ground. A ladder placed against the house with a base at the angle of 75 degrees. Determine and state the length of the ladder to the nearest foot. So, once again, opposite, length of the ladder is hypotenuse. So we know that this is 15. We're going to bust out with sine, because sine is so sine 75 is equal to 15 over h, cross multiply h times the sine of 75 is equal to 15, and then I just divide out by the sine of 75. And then h is equal to, and we get 15.5, nearest tenth would be 15.5. All right. Number 300, shown the two diagrams below. We know that these are similar triangles. Now remember, we know two things. One, their angles are all equal. And then two, we know that the ratio of the sides is the same. So tangent theta, now theta is this angle right here. So what angle is also going to be theta in this triangle? So if you look, that's 90. These are equal. So that makes this also the measure of theta. And theta says it's 3 over 7. Remember, tangent is equal to the opposite, theta, over the adjacent. So that means 3 is the opposite and 7 is the adjacent. So this should be 3 and that should be 7. So in our triangle, all we have to do is figure out what the value of x in the nearest tenth. So what we can do is two options. Number one, we use the ratios to solve. So we say that the tangent of theta is equal to 7 over 3. And in the other triangle, right, the tangent of theta over here, this is the opposite, that's the adjacent, is also 2.4 over x. And these two ratios are going to be equal. So we can just do 7 over 3 equals 2.4 over x, and we can solve. 7. Now what we would normally do is cross multiply. This is going to be 7.2, and then we divide by 7, and x is equal to, and we get 1.028 nearest tenth. Getting the answer a little bit off. All right. The other option is to actually figure out what theta is. So if the tangent of theta is equal to 3 over 7. Oh, I wrote 7 over 3. That's why we're getting the wrong number here. 3 over 7. I'm wondering, like, what is going on? All right, let's fix this. So 7 times 2.4 divided by 3, and there's 5.6. And that's how this should look. So 3x divided by 3, right, is equal to 16.8. And we get an answer of 5.6. Now, if we do this method, we're going to take the tangent inverse of both sides and get the angle measure. So tangent inverse 7 is that lovely degree measure right there. And then we can use that to figure out x. So here we're going to do tangent of theta is equal to, this is 2.4 over x, and we just cross multiply. X times the tangent of theta is equal to 2.4. I divide by the tangent of theta. Remember, theta is really this number right here. So 2.4 divided by the tangent of that answer right there. And we get 5.6. So same thing. That's another way to do that. Two options. Okay? All right, we're going to stop the video there. I'll make a video 2, and I'll send it out a little bit.